Notice which direction this plane is taking off. It's going from left to right, okay? If anything, for this whole lesson, you need to understand that we will be going from left to right. Now, that being said, is this plane going up or going down? Going up from left to right, okay? Do not go from right to left on this lesson. It won't work. So, for this lesson, this is assuming that x is increasing. If we're looking at a x and y axis, if we go from left to right, x gets bigger, right? On the left, x is negative. On the right, x is positive. Going from left to right, it gets bigger. Yes?
But does y have to increase also?
That's exactly what we're going to be looking at. If y is going down, then we're going to say it's decreasing. If y is going up.
What about parallel?
If it's flat, there's a couple ways you can say. I like to say the change is constant. Okay? In other words, there is no change in y. It's constant.
So are you giving it a title based off of x or y? So if x is increasing and y is decreasing, what do you get? Well, I guess.
You would say it's decreasing.
Okay, so you're basing it off of y.
You're basing it off of y. That's right. All right, so here's your options. Okay. For function change, you can either have increasing, you can have decreasing, or a lack of change, which we will call constant, of a function as the x values increase. So that's why you have to go from left to right, because if you went from right to left, the x values would be decreasing. So here's some definitions to consider when we're answering these questions. When we say a graph is increasing, that means that the y values or the f of x values are going up. They don't have to be going up by a lot, okay? They could be shooting up steeply, or they could be going like this. Either one of those is increasing. Okay, now decreasing would be going down to a certain degree. And constant would be like this, right? A flat line. Now, sometimes we can't even define the change in the y value. And we cannot determine the change in the y value. We say that it's undefined. An example of that would be a single point by itself. If you just had one point on the graph, why would the change in y be undefined? Well, that's because there's no points around it, right? It's kind of like saying the temperature right now is 50 degrees, but I don't know what it was before, and I don't know what it's going to be. Well, if that's the case, then how can we say if the temperature is increasing or decreasing? We don't have any clue about the data before or after, right? And so with a single point, you can't really say that the y values are going up or going down. So for example 1, don't know why I don't have that labeled, but this is example 1. Following is the graph of the function f of x. You don't have to write all this down. Describe the change in f of x as x increases. Okay, now you can go ahead and sketch this graph.
Oh, that is not straight line.
The first question I'm going to ask you is, where is f of x increasing? Does anybody want to chime in on that? Where is f of x increasing? Say that one more time. Not infinity. Yeah, okay, so all the way from negative infinity up until we get to the x value of -3, it's going up, right? Now, is it increasing at -3? No. It increases up to -3, but since there's nothing to the right of -3, we won't include it, so we'll use a parenthesis, just like this. Okay? This is two different ways to write the same thing, but make sure that you put a parenthesis around -3. If the point just stops like that, you cannot put a bracket. I can't be more clear about that. Now you have to look at the rest of the graph. Is there anywhere else where the y values go up from left to right? No. So we can finish that particular aspect. We know that that's the only place where f of x is increasing. And remember, your answer should be in terms of x. I guess that's where students get confused. Okay, the answer is in terms of x, but that explains what y is doing, okay?
So it
So,
has to be a parentheses if it just stops.
right,
How do you put a why when?
you wouldn't. You would never have a bracket.
Okay.
You would never have a bracket. It's a great point. Thank you for asking that. You would never have a bracket because, like if you had a bracket at -3, that means there's points after it. So then you're excluding those points. So it's kind of like a contradiction, right? You can't have a bracket for increasing and decreasing. All right, so let's ask the question now, where is it decreasing? If we look at the graph, it's going down, not at 3, but anything after 3, the graph moves down, and it keeps decreasing forever, right? And so we would say from 3 to infinity. Again, the answer is in terms of x, but that explains where the y values are going down. So we're about to address that. That's okay. What was I going to say? Lost my train of thought. No, that's okay. I'll come back to it in a second, I guess. But yeah, it goes down from 3 to infinity. Again, no bracket around 3. Okay, so that middle line is where it's constant. And sometimes you will have a bracket for constant, and I'll talk about that in a little bit. Most of the time not, but I can't say never. But anyways, we can see that there is a horizontal line here from -2 to 2. Now again, we can't say anything about the endpoints because there's nothing to the left and right, so we can exclude those. But we can say from -2 to 2, the graph is constant.
Why would that be a negative?
Which one, this one? Oh, that's what I was going to say. That's exactly what I was going to say. Okay, so here's the mistake I've seen. Somebody will answer this question and put 2, negative infinity. Right? That's that's what's happening to the y values, right? Your answer should be in terms of x, not in terms of y. Okay? In terms of x, from 3 to infinity, the graph goes down. Okay? So your answer has to be in terms of x, but it's explaining what y is doing. Okay? So that's why the answer is not negative infinity, because it's what x is doing.
If you were to do that before, you would have had negative infinity to 2.
Right, if you were doing that in terms of y, it'd be from negative infinity to 2. But again, the answer is in terms of x, where y is increasing.
So, and this is always going to be in terms of x, or is that like another crazy?
It's always in
thing
terms of
where you
x.
have to do and it's like y? Like the domain and range.
It's always in terms of x. Now we do have undefined changes in f of x. All of those endpoints, all of those endpoints are where f of x is undefined. -3, -2, 2, and 3. And if we look at the graph, we can see that these endpoints are where the change is undefined. Anytime you have an endpoint, you have an undefined change because there's either going to be something missing before or something missing after. So the change is not evident. There's a word for that in calculus, which you guys are going to learn very soon, and that's called the tangent line.
I don't know about that.
The tangerine line. Yes, exactly. Example number 2. Similar thing. We're going to determine what the change in f of x given the following graph. Okay, so again, we want to answer, on this worksheet, you're answering 4 things, where it's increasing, decreasing, constant, and where the change is undefined. Okay, so first of all, does anybody want to tell me where this graph is going up from left to right? Raise your hand if you know. Yes. Nope. From 0 to 1.
Oh,
You're looking at the y value. Again, it's the x value where the y goes up. So it'd be from 0 to 1. That's okay if you don't have to. If you get it, that's the most important thing. As long as it's clicking.
What if it's not really clicking?
then you have problems.
We really need to write it as 0.
Is there anywhere else where the graph is going up? No. It's either going to be going down or staying the same, so we'll talk about that. So go ahead and answer this question. Where is it going down? Somebody raise their hand and give me the first interval. Yes. Yes, so from -3 to 0, the y values go down. Again, the answer is not 4 to 1. We're not asking what y values go down. We're asking where they go down in terms of x. So from -3 to 0, the graph goes down. Okay, how about the next time it goes down? So 1 to 3. Right, good. Okay. So when x goes from 1 to 3, the y values go down. And then finally, from what to what? 3 to infinity. That's correct. So here's your answers. Where does the graph stay the same? Maybe we want to answer that one. Say that again. Negative infinity to 3, the graph stays the same. In other words, from here to there. Negative infinity, -3. Thank you. And finally, where is the graph undefined? Somebody want? Shh. Where's the change in f of x undefined? The first point. At x equals what?
But there's nothing missing before it or after it.
Okay, I'll talk about that. But okay. Can you really say that it's staying the same right there? No, it's transferring from. So on the left, it's staying the same. On the right, it's going down. So it's not like you can pick one or the other. You see what I'm saying? It's a corner. So you really can't say one or the other. It's a transitional point. Okay. You can't say it's going up, and so you've only got one other choice. That goes back to the concept of the tangent line. And again, you're in pre-cal, so I don't expect you to know too much about the tangent line other than the only time that you could actually say that it exists is if it was like curvy. Okay? That's the best way I know how to explain it. If it's curvy, then you could say, yeah, that point right there is whatever, right? But it's jagged. Okay, whenever you have a jagged point like this, it's going to be an undefined change. It's an abrupt change, okay? So you really can't say it's staying constant or going down. Same thing for this one, okay? It's a jagged transition, and so you really can't say it's going down or up there. It's a transition between the two, and it's an abrupt change. It's not curved. So also at x equals 0, you're going to have undefined change. And the third one is at x equals 1. It's an endpoint. And so you don't have to, okay, so guys, you could put x equals 3, but you don't have to because there's no point on the graph. If there's no point, then you don't have to say whether it's constant or undefined or whatever.
What do you mean there's no point?
At x equals 3, there's no point. Okay? Example 3. All right, let's just look at where it's increasing.
So would that mean that -6 is not an undefined thing? It's curvy?
I'll talk about that.
Oh my god.
I'm not there yet. I'll talk about it. Where is this graph going up? It's the first question we're going to ask. Somebody want to raise their hand? Yes.
0 to 3?
Negative.
No.
Yeah. Okay. That'll work. 0 to 3. How about the first place where it goes up? Good job. -6 to -4. Again, we're looking at the x values. You would not say 2 to 6. That's the y values. Say the x values. From -6 to -4, the graph goes up. And then I'll go ahead and chip in on this one from 3 to 6. Is there anywhere else it goes up? No, so those are your answers.
Okay, the first one will be parentheses. So is there like a rule to that whole like that parentheses and that side parentheses thing? Like if there's no point there, is it not?
For increasing and decreasing, it'll always be in parentheses. For constant, I will talk about in a second. Where is it going down? So how would you... We're talking about x. Negative infinity. That's an arrow. So from negative infinity to -6, it goes down. All right, next.
From -4 to 0.
Yes. And that's it, right? So we're good on increasing, decreasing.
You didn't talk about the curve.
I'm not there yet. I'm almost there. I'm there. I'm right there at it.
Remember those rules Mr. Savage has?
Yeah, I was to the right, everything's on the board.
Oh, stupid crap. I was dumb.
Okay. Imagine this actually being better if the hill's going up. All right, I'll tell you what. Let's look at it this way. Okay, imagine if this were a hill
The hail.
and you were climbing up, climbing up.
See, stop there.
When you get right here, it's flat, right? It's flat. Now, it's flat until you get here and then it goes down, okay? Since it's flat, okay, just like this is flat, whoops, that's not flat. Just like that is flat, we can say that it is a constant change. Only at that single point is it flat, because once you go past that, you're going to start going down the hill again. Also works for this way, right? Normally you wouldn't go down a hill like this, but hold on. So you'd be going down, you'd be going down. Right here, it'd be flat, and then you'd be going up again. So at this point, it'd be flat. It's constant.
What about the
So at this point right here, it's flat, right? At one single point, it's flat because it goes from down to up. It's not jagged. If we go back to this example, if you theoretically were to go into something like this and you were walking down and up, there never would be a flat point. Right there, you'd have to straddle it, right? Like there's nowhere to stand. So think of it that way. Imagine yourself walking on the graph. So this would actually be a constant at -6.
So if there was a point on the graph, it would like a hill, it would be a constant. It wouldn't be undefined.
Ask your question again.
If there was like a hill on the graph and there was a point where you put it, it'd be constant. It wouldn't be undefined.
As long as it's not like a V.
Yeah, but I mean if it's round. If it wasn't like, there was no point there?
Yeah, there doesn't have to be, there is a point there, but I see what you're saying, like, there doesn't have to be a defined point there for it to still be constant. You can imagine that if you were standing there, it would be flat at that single point, okay? So at -6, it's constant, and then of course, right here, we can see it's flat for sure, right? So we can also say from, yes, exactly.
It's constant, but it follows the rule.
All right, so that brings us to the fourth point, which is undefined change. And it's going to be at -4 and 6. Let's take a look and see why. So again, at -4, it's not a smooth transition. It's jagged. That's called a cusp. Just, you don't have to know that, but if it kind of goes curvy and then straight like that, it's called a cusp. So it can be undefined at -4. And then also here, but it's still not a perfect, it still kind of goes like this, okay? That is not completely smooth like this one. I know it's difficult at first, but you guys will get it. I'm trying to explain it the best way I know how. So the difference between whether it's jagged or curvy is going to determine whether or not it's undefined.
So every single time it's a curve, it's going to be constant, right?
That's right. As long as it goes from down to up, yes, or up to down. Last example. This would be example 4.
Wow.
Okay, so let's just,
No constant.
good point. Yeah, actually, yeah, there are. Flat lines.
Oh, -5.
Oh, I mean like the curvy one.
That's right. First of all, where does this graph go up?
-5 to negative.
Raise your hand if you got this. Where's the graph go up? Yes. This is the only point it goes up. It's from 5 to infinity.
That's the only point.
Yeah, look at it.
Where else does it go up?
-5 to.
We're not going left, right, to left.
You said from -5 to what?
Oh, never mind. That's completely wrong.
All right, so it's the only point it goes, place it goes up. How about down? Raise your hand if you got this one. First place where it goes down.
I'm just not that guy.
That's right. From negative infinity to -5, it goes down. Okay, and then we have from 1, whoops, all the way up to, but not including 3. So that's obviously in parentheses. And then from 3 to 5, it goes down. Okay? And then constant. From -5 to -2, and from -2 to 1. And then finally, undefined. We have several points right here at -5. It's an endpoint, so there is no up or down. Right here at 1. Now again, you don't have to list -2 because there's no points there at all. You would technically be correct, but if there's no point there, then you don't have to list it. At 1 and 3, correct. At 3, there is a single point, so you need to list that as undefined. And finally, at 5. So there's your answers. As you guys go through this worksheet, make sure to ask questions, work with somebody. Again, you're only answering increasing, decreasing, constant, undefined on here. You don't have to worry about the questions that talk about relative min and max, or absolute max. We'll talk about that later on in the week.